Why the name Methuselah? B1620-26b, also nicknamed Methuselah, is often referred to as the oldest known planet. The name comes from the biblical figure Methuselah, the oldest person mentioned in the Bible. While not an official designation in scientific literature, Methuselah is often used informally because of the planet's extreme age. Within the Simbad astronomical database, the planet is still listed as PSR B1620-26b. What this discovery means. The capabilities of modern science are astounding. Who would have guessed that some planets are nearly as old as the cosmos itself? Perhaps the most enigmatic aspect of this discovery is that we may not even be sure if Methuselah is the oldest planet. The likelihood that other planets of similar or even greater age exist is high. Compared to this 13-billion-year-old giant, Earth is just a cosmic infant. Final thought. What do you think about Methuselah, the ancient planet? Milky Way. Does its discovery show us how powerful and strange the universe truly is? Globe showing Europe Africa. Do you believe there could be planets even older waiting to be discovered? The mass of our Milky Way's earliest planet was precisely determined by NASA's Hubble Space Telescope. The ancient planet has experienced a notable history due to the fact that it is in an improbable, tough neighborhood. What neighborhood is that? And how could researchers quantify such an ancient planet? If you would like to learn more from our videos, please give us a thumbs up in support. Sign up for Simply Space and eagerly anticipate the videos that will be here waiting for you. Later, let's start our voyage over the emptiness of the cosmos. B1620-26b, PSR, is a planet that circles a pulsar, PSR B1620-26. Messier 4, in the globular cluster, is situated around 12,400 light-years away in the Scorpion constellation. The exoplanet is also the oldest existing and recognized exoplanet, because it is believed to be 12.7 to 13 billion years old. The planet's age is over twice that of Earth, which is 4.5 billion years old. About a billion years following the birth of our cosmos during the Big Bang, this young planet came into existence. Interestingly, this planet revolves around an odd pair of burnt-out stars in the cluster's dense core, which contains over 100,000 stars. How can you tell if this object is a planet? Long before Earth and our Sun even existed, there was a planet as big as Jupiter, formed around a star similar to today's Sun. 13 billion years later, the mass of this oldest and most distant planet was precisely measured by NASA's Hubble Space Telescope. According to Hubble's analysis, the object has 2.5 times the mass of Jupiter, confirming that it is indeed a planet. Its very existence provides compelling evidence that the first planets were formed rapidly, within a billion years of the Big Bang. This led astronomers to conclude that there may be many planets in our galaxy. The old planet has had an amazing history because it landed in an unlikely, harsh neighborhood and orbits a strange pair of burnt-out stars in the crowded core of a globular cluster. The tale of the planet's discovery. The finding of this planet started in 1988 when astronomers under the direction of Donald Backer found the pulsar known as PSR B1620-26 in M4. It is a neutron star that rotates roughly 100 times per second and regularly sends forth lighthouse-like radio pulses. Since the two stars orbit each other twice a year, the white dwarf was swiftly identified due to its impact on the clock-like pulsar. Later, astronomers observed more anomalies in the pulsar, which suggested that a third object was orbiting the others. This new object was initially believed to be a planet, but astronomers also conjectured that it might be a solid-state star or a brown dwarf. The discussion regarding its actual identity persisted into the 1990s. The argument was terminated when astronomers were finally capable of measuring the actual mass of the planet by means of a clever celestial investigation. They used Hubble data from the mid-1990s to research M4 white dwarfs. After sifting through these observations, they managed to locate the white dwarf circling the pulsar and calculate its temperature and color. Utilizing evolutionary models computed by Brad Hansen from the Department of Astronomy at the University of California, Los Angeles, astronomers were able to calculate the mass between the white dwarf and the Earth. A complex dance of stars and planets. A binary star system featuring an aged neutron star and a white dwarf created a network of perplexed orbits. The white dwarf was flung out of its initial position by the massive planet, while the planet was plunged into a circumbinary orbit, a broad orbit circling both the neutron star and the white dwarf. This gravitational recoil shifted the fresh double star system outside the globular cluster's core and into a less dense area, lowering the likelihood of further stellar interactions. The planet then settled into a long, slow orbit around the neutron star and its companion at a distance of roughly 2 billion miles, comparable to Uranus' orbit around our Sun. Over billions of years, the Sun-like star evolved into a red giant, releasing material into the neutron star. This mass accumulation caused the neutron star to spin up,